Welcome to True Projects. In this video, we are going to explain about the project that is anomaly detection in network traffic using advanced machine learning techniques. So before getting into the execution, first let us understand what is the project about. In a corporate network where thousands of devices are connected, data flows continuously. That is through emails, file transfers, cloud applications, and video conferencing. So within this constant traffic, a malicious actors may attempt unauthorized logins, inject malware, or launch denial of service attacks. These activities often blend in with normal operations, makes it difficult to distinguish between legitimate and harmful users. So, this is where anomaly detection becomes essential. It identifies unusual patterns in the network traffic that could indicate potential threats. The difficulty, however, lies in the dynamic nature of network behavior. What appears normal in one context, such as sudden spikes in traffic during business hours, may be considered abnormal in another. Additionally, the complexity of network features and the challenge of clearly defining normal versus abnormal activity make detection even harder. So, as attacks continue to grow more sophisticated, the need for advanced anomaly detection methods has become a critical focus that is the important focus in cybersecurity research. Effective systems must adapt to evolving traffic patterns, reduce false alarms, and ensure that threats are detected before they cause serious damage. Here, when building a network intrusion detection system, several practical challenges arise. One major issue is class imbalance in the datasets. That is, most network traffic is normal, while actual attacks form only a small fraction, that is, only small amount. This imbalance often causes models to favor normal traffic, leading to missed detections of rare but critical threats. Another difficulty is feature complexity. Since network traffic is described by many attributes such as duration, protocol type, packet size, and connection counts, all of which interact in complicated ways. On top of that, in large scale networks, the system must maintain fault tolerance so that it continues to function even if some components fail, and it must handle load balancing to distribute processing efficiently across servers. So, these challenges makes it difficult to build anomaly detection systems that are both accurate and efficient. As a result, research continues to focus on addressing these limitations and designing methods that can reliably identify intrusions in real-world, large-scale network environments. So, the objective of this project is to detect anomalies in network traffic by implementing and evaluating multiple machine learning models using NSL KDT dataset. Both supervised and unsupervised approaches are explored here, focusing on models such as isolation forest, naive Bayes, XGBoost, light GBM, support vector machine. Since the data is often complex and high dimensional, here principal component analysis, that is PCA, principal component analysis, is applied as pre-processing step to reduce the number of features while retaining the most significant variance in the dataset. So this step helps to improve the computational efficiency and also allow the models to focus only on the most relevant aspects. And here, each model is then analyzed for its ability to handle common challenges in anomaly detection, including class imbalance, feature complexity, and scalability in large network environments. By systematically evaluating these algorithms across accuracy, precision, recall, and generalization to unseen data, the project provides insights into their relative strengths and weakness. This comparative study supports informed decision making for selecting and optimizing machine learning models in practical network security applications. And to further improve the performance of this project, here we have employed voting classifier model. It's a combination of multiple models. So here we have combined boosted decision tree with bagging using random forest. This ensemble approach is designed to strengthen predictive performance and improve the robustness of anomaly detection by leveraging the complementary strengths of different models. And here, to enhance the transparency and trust in the system's predictions, explainable AI methods such as LIME and SHAP have been used in this project. So these techniques makes it possible to analyze feature importance and better understanding how the models arrive at their decisions, which is especially critical in security applications. And in addition, here we have developed front-end using Flask framework. allowing users to input network traffic data and directly view predictions. To ensure privacy and security, authentication features are integrated, making the system accessible for practical testing while safeguarding user data. So, this is about the extension part. Now, moving on to the implementation. So, these are the steps followed to implement this project. Let us understand each of them step by step. So, here in the first step, we will be importing all the necessary libraries for data handling, visualization, modeling, imbalancing, that is, data balancing, model saving, and for XAI models. And in the second step, we will be reading the data, check shapes, D types, that is the data types, and class distribution, and identify categorical features and numerical features for later pre-processing. Then comes pre-processing. So here we will be verifying and handling missing values. And then we will be dropping the exact duplicates to avoid bias. And then we use IQ score so that we carefully don't remove legitimate rare attacks. And then we will be deleting unnecessary columns. We will be dropping the unnecessary columns. Then comes data visualization. So here we have used correlation matrix to inspect correlation among numeric features to spot redundancy and multicollinearity. And in the sample outcome, we plot class distribution and few feature histograms, that is box plots per class to understand separately. And then comes label encoding. So here in this step, we will be converting all the categorical columns to numeric. And then comes feature selection. So here we will be using principal component analysis to select the most important features. Then comes desampling the data. So here we have used SMOTE, that is synthetic minority oversampling technique, to balance the minority class. And then in the next step, we set X variable to the selected engineered features and Y to the target label. Ensure that the final feature set matches what the model expects. Then we split the data into train and test sets. So training set is used to train the model and testing set is used to evaluate the model on unseen data. Then we will be initiating the models and training the models to do the prediction. And then we will be evaluating all of them using accuracy, precision, recall, and FN score metrics. And that scores will be visually represented through graphs for comparison purpose. And then the best performing model will be saved for the future use. Coming to this XAI techniques, that is LIME and SHAP. So here we have used LIME, that is local per prediction explanation, showing which features push the decision. Then coming to SHAP, we have used SHAP, that is the global and local importance. It uses tree explainer for all the models and to keep the explainable, that is explanations, human readable. After that, we have developed a front end that is using Flask framework. So here we have set up registration and login that is supported with the SQLite database. And in the front end, users, they will be able to provide feature values that will be pre-processed at the backend. It will be fed to the train model, and then train model will be giving us the outcome. That is the prediction. And these are the algorithms used in this project. To implement this project, basically we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And in software requirements, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's get into execution. To execute, we are supposed to open the code folder that contains source code files. So let's open it. These are the source code files. Here, this folder contains the algorithm information that will be loaded into the project code during runtime. And in this, we have the data set. So these are multiple files. We will be extracting data from it. And then we will be doing pre-processing and store it into this file. And this is the static folder. This folder contains files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here in this templates folder, this folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. In this, we have test cases that we will be using in the front end. This is the app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. This is the notebook file. It's a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. To execute, copy the path of the code folder and then open Anaconda prompt. Here it is open. Now give the command cd, give the space, paste the copied path. Now click on enter. So here we have not copied path completely. Let's copy it again. Give the command cd, give the space and give the path. So here current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and click on enter. So this command will execute Python script and check for runtime, that is syntax issues and runtime errors. After running the app.py file, Flask framework will be hosting the application locally at the default address, which is the localhost and the port. So this is the port and this is the localhost. Now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will be pasting in that. So paste the link here, click on enter. So this is the web page of the project. This is developed using Flask framework. So click on sign up first and create the account if you have not created. I have already created, so I will be directly signing in. So click on sign in, give your username and the password. I have entered my username and the password. Now click on sign in. We have signed in successfully and redirected to prediction page of the project. So here you can see inputs, right? That is the parameters. So these are the inputs that we're supposed to give for doing the prediction. Let's understand each of them. The first one we have is the num file creation. It's a number of file creation operations initiated during the connection. This can indicate suspicious activity if unusually high. Then we have source bytes. So these are the number of data bytes sent from the source to the destination. Then we have different SRV rate. So it is the proportion of connections to different servers than previous connections. This helps to identify abnormal service usage. Then we have wrong fragment. So it is the number of wrong fragments in the packets, can indicate malformed or malicious packets. Then we have destination bytes. These are the number of data bytes sent from destination to the source. Then we have duration. So here we have duration. It is the total duration of the connection. Unusually long or short connections may indicate anomalies. Then we have num shells. It is the number of shell prompts invoked. High values could signal compromise. Then we have SRV count. So here we have SRV count. It is the number of connections to the same service as the current connection in a given time window. And here we have destination host different SRV rate. It is the proportion of connections to different services on the destination host used to detect scanning or probing attacks. Then we have count. So here you can see we have count. It is the number of connections to the same destination host as the current connection with a time window. Then we have land. So it's the binary feature indicating if the connection is formed to the same host and port, can signal reconnaissance or DDoS attack. Then we have num compromised. So it is the number of compromised conditions detected. It indicates potential intrusion. Then we have protocol type. It is a type of protocol used, that is TCP, UDP, ICMP. Categorical feature affecting connection behavior. Then we have num root. It is the number of root access attempted during the connection. High values indicate elevated privileges misuse. Then we have root shell. So it is a binary feature indicating if root shell access was obtained. Then we have is host login. So here you can see is host login. It indicates if the connection is from a host level login. Abnormal patterns may signal compromise. Then we have destination host same SRC port rate. It is a proportion of connections to the same destination host and source port. It can indicate scanning or repetitive attacks. So this is all about the parameters. Now let's enter them. So let's open this test case file, open test cases, open samples. So here let's apply filter to class 0. Click on OK. And now let's check with this case. So here num file creations are 0. SRC bytes are also 0. Then we have different SRV rate, that is 0.06. Wrong fragment is 0. Destination bytes are 0. Duration is 0. Num shells are 0. SRV count is 6. Destination host SRV rate is 0.07. Count is 235. And here land is no. So 0 refers to no. And number of compromise are 0. Protocol type is 1, 0. Root shell is 0 and all other values are 0. So here 0 refers to no, no, and the last one is 0. Now click on submit. So this given input, it will be pre-processed at the backend. It will be feed it to the trained model, and that trained model will be giving us a prediction. So here we got the prediction that is not defective. So the predicted output indicates that the item or the network traffic is normal and does not show signs of anomaly defect. So no action required. Continue with regular monitoring. It is suggesting us to continue with the regular monitoring. Now let's do the prediction with other test case. So let's check with this one, where number of file creations are 0, source bytes are 0, different SRV rate is 0.05, wrong fragment is 0, destination bytes are 0, duration is 0, number of shells are 0, SRV count is 20, destination host different SRV is 0.0531. So paste it. And here we have count as 208, land is no, number of compromised are 0, protocol type is 1, num root is 0, and then root shell. Root shell is 0, that means no. Is host login, that is no. And then the last value is also 0. Now click on submit. So here also it is showing that non-defective. Here class 0 refers to non-defective case where there is no attack. So these are the test cases where there is no attack. Now let's check with the class 1. So let's give input as this feature. I mean this test case. Click on home. So here number of file creations are 0. Then SRC bytes are 2881. Different SRV is 0, 0, 0, and we have zeros up to number of shells 0, 0. And then SRV count is 7. Then we have destination host, that is 0.04. Then we have count as 7. Land is no. Number of compromised are 0. Protocol type is 1. Num root is 0. Then we have root shell 0, that is no. And is host login, that is also no. And destination host is 0.37. Click on submit. Here we got the prediction that it is defective. So here the predicted output indicates a defect or anomaly that has been detected. Immediate attention is recommended. So here it is recommending that to investigate the cause of the defect or anomaly and take correct action as soon as possible. Now let's check with the last case. So let's check with this case. So click on home again. Number of file creations are 0. SRC bytes are 147, 0, 0, 105. And then duration is 2730. Number of shells are 0. SRV count is 1, 0.741. And then number of compromised are 0. Protocol type is 2. And then we have number of roots are 0. And then no root shell, no host login, and the last value is 0.99. Now click on submit. So here also we got the prediction as defective. So there is defect in this test case. Now let's check with the graphs. Click on about. So here the first graph which we have is the sample outcome graph. Here on x-axis we have the categories that we are predicting. So this is the normal one and this is the attack one. And here on y-axis we have the count of each category. Close this. And here we have heat map. This shows the correlation between features. And here we have variance by PCA components. And here we have model explanations. This is the confusion matrix. And here we have Lime explanation, SHAP value, which shows the feature importance. So this shows the feature importance. And here we have SHAP waterfall plot. And here we have performance metrics. Here, this is the accuracy comparison graph. Here on x-axis, we have all the models that we have trained, and on y-axis, we have accuracy. Accordingly, we have for the other metrics, that is precision, recall, and FN score. So now click on sign out. In this way, just by giving inputs to the application will be predicting whether the case has attack or not. That is whether it is defective or non-defective. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.